Hi, today we're looking at foundation level maths. This is from November 2022. We got the Pearson Edexcel exam board, and this is paper 1, the non-calculator paper. Question 1. Write 0.3 as a fraction. So if we think of our decimals, the first digit after the decimal point is the tenths, and we've got 3 of them. So we've got 3 tenths. Question 2, 3 squared, so that means 3 times itself. So 3 times 3, so we've got 3, 6, 9. Okay. Question 3, work out 20 divided by 3 plus 2. Now 3 plus 2 is in the brackets, so we're going to do that first. So 3 plus 2, we've got 1, 2, 3, 4, 5. So this is 20 divided by 5. So let's do our 5 times table. 5, 10, 15, 20. So that's 4. Question 4. Write down a factor of 60 that is between 8 and 14. So the factors are all the numbers that go into 60 with no remainder. So for example, we've got 1. We're also going to have 60. So let's think of other numbers that will go into it. Well, it's even, so 2 is going to go into it. And 2 is would go into 60 30 times, because 30 is half of 2. But neither of those are in this range yet. Let's think what other numbers. Well, it ends in a 0, so that means 10 must go into it. There you go, we'll settle with that. You could also have 12, goes into it 5 times, but I think 10 is probably the nicest one to go with. Question 5. Simplify 3 times W times 5 times T. Well, let's start with the numbers first. So we've got 3 and we've got 5. And because they're all times, they're all multiplying, you can do them in any order. So let's start with a 3 times 5. 5, 10, 15. And then we've just got the letters and we put them in alphabetical order. So we put the T and then the W. And because it's algebra, we don't need to put the multiply signs in. We can just have it as 15 TW. Question 6. Faye is planning a trip to a theme park for 1 adult and 2 children. These are the costs for the trip. Total cost of petrol is £23. Tickets to the theme park is £33 for each adult, £24.50 for each child. Meals are £15 each adult and £10 for each child. Faye has £200 to spend. She pays all the costs. How much money does she have left? And this is a 4-mark question, this one. So basically need to work out the total costs and then take it away from 200. So we've got petrol, so we've got the 23. I'm going to write it over here. So we've got £23. Tickets to the theme park, we've got 1 adult, so we've got £33. But then we've got 2 children. So we've got £24.50. And we've got another £24.50. Then the meals, we've got £15 for the adult. And we've got 2 children, so we've got 10. And then we've got another 10. So we can add all of this together. Now, because we've got some decimals here, what I'm going to do is just, to make it easier, I'm going to put zeros, so we've got something to add to. So these are all zeros down here. So we'll have 0 at the bottom. 0 plus 5 plus 5 is 10. So 0, carry the 1. Decimal point here. 3 plus 3 is 6. Plus 4 is 10. Plus 4 is 14. Plus 5 is 19. Plus 1 is 20. Then 2 plus 3 is 5. Plus 2 is 7. Plus 2 is 9. 10, 11, 12, 13, 14. So we've got a total of £140. Got £200 to spend. So if we take away the £140, we'll find out how much she's got left. 0 minus 0 is 0. 0 minus 4, well, we can't take 4 away from 0. So take 1 off of the 2 and pass it over. So we've got 10 minus 4 is 6. 1 minus 1 is 0. So she's got £60. Question 7. Here is a list of 8 letters. Okay. Write down the mode. Well, the mode is the one that occurs the most, and hopefully you'll be able to quickly see, well, we've got 2 B's, we've got 1 C, and we've got several A's. So A is the mode. Note the mode isn't how many times it occurs, it's just which one occurs the most. So it's the A. One of the 8 letters is going to be picked at random. On the probability scale, mark with a cross the probability that this letter will be B. Now, well, let's take a look at these again. So we've got 8 of them. So the probability is going to be out of 8. And how many are B's? We've got 1, we've got 2. So 2 out of 8, or 2/8. Now we can simplify this because both numbers are even, so they're divisible by 2. 2 goes into 2 once. And 8 divided by 2, 2, 4, 6, 8. It's 4 times, so we've got 1/4. So a quarter is going to be halfway between 0 and a half. So we want to put our cross here. And then finally, find the probability that this letter will be C. So again, the denominator is going to be 8 because we've got 8 in total. How many of them are C? Only 1. So we're going to have 1/8. Okay, question 8. Solve m minus 3 equals 4. So we want to have the m on its own. So we're going to move the minus 3. When we move it, the sign changes. So that becomes a plus 3. So 4 plus 3 is 7. And now we've got part B. Solve 3n plus n equals 24. Well, if we've got 3n and we add another one on, that's going to give us 4n equals 24. Well, if we know 4n and 24, if we want 1n, we're going to need to divide by 4. So it's the same thing again. We're going to move the 4 to the other side, and we need to do the opposite operation. So we're multiplying here. So if we move it to the other side, it's going to become a divide. So 24 divided by 4, 4, 8, 12, 16, 20, 24. That's 6 times. Question 9. Find the value of y. Well, the total degrees in a circle are 360. So if this bit is 70, if we take that away, what's left will be our answer. So 0 minus 0 is 0. 6 minus 7, well, we can't take 7 away from 6. So we can reduce the 3 by 1, so it becomes a 2. Now we've got 16 minus 7, which is 9. 2 minus nothing is still 2. So we get 290, and we can put the degrees in there as well. So we've now got part B. Give a reason for your answer. And we haven't written it down yet, but it's what we said. So basically the total degrees, well, we can say in a circle, or I'm actually going to write it around a point. That's how they like to describe it. Is, or are 360 degrees. question 10. Actually, we don't need that bit yet. 10a. A shop sells jars of coffee. Each jar of coffee costs £4. Michael has £23. Work out the greatest number of jars of coffee Michael can buy. So we're going to do our 4 times table. So we've got 4, 8, 12, 16, 20. 24 would be too many, so we're going to stop at 20. So 5 lots of £4 is £20. So the answer is 5. And part B. In a sale on Wednesday, jars of coffee are sold at half price. Michael thinks that he can now buy exactly twice the number of jars of coffee for £23. Is Michael correct? You must give a reason for your answer. Okay, so if they're half price, they were £4, so £4 divided by 2 is going to be £2. Okay. So we want to see, well, how many 2s would go into 23? We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So it's actually 11. So 23 divided by 2 is 11. Remainder 1. He thinks he can buy exactly twice the number of jars, so we can say 11 is greater than 10. And if we do 2 times 5 equals 10. So this is the twice. So he's saying we should be able to buy 10. We're saying, well, no, actually, he can buy 11. So we can write it like this. Or we could put something like twice 5 is 10, not 11. But it's only worth 1 mark. So as long as you put some sort of explanation on there, probably involving the 11, then that's going to be fine. Question 11. Here are 2 triangles on a grid. Triangle B is an enlargement of triangle A. Write down the scale factor of the enlargement. So the scale factor means how many times bigger is it? So what we can do is just look at one of the sides. So I'm going to look at this top side. It's 1, 2, 3 across. And the B is 1, 2, 3, 4, 5, 6 across. Well, 6 is double 3, so the scale factor is just 2. It's 2 times bigger. Okay. On the grid, mark with a cross the centre of enlargement. Okay, so that's going to be back on this one, the centre of enlargement. So what we want to do with this is use our ruler and draw a couple of lines. So what we want to do is pick a couple of points on the triangle. So I'm going to pick this one here. So we want the same point on the small and the large triangle, and just draw a line. And then we're going to do the same thing from one of the other corners. So we'll do it here. This corner and this corner. And wherever they cross, that's going to be our centre of enlargement. Okay, now for part B. Here are 2 parallelograms on a coordinate grid. So we've got C and we've got D. Parallelogram D is a reflection of parallelogram C. On the grid, draw the mirror line and write down an equation of this mirror line. Right, so this is reflected here. So the mirror is going to have to be somewhere down the middle. So if I look at these 2 points, we've got essentially 2 squares between them on the diagonal. So halfway would be there. If we look here, we've got 1, 2, 3 squares on the diagonal. So halfway would be halfway between that square. And if we do it up here as well, we've got 1, 2, 3, 4 squares. So halfway would be here too. So all I need to do is connect these dots. So that's the mirror line. Write down the equation of this mirror line. Okay, so the equation is going to look something like, it's going to be y equals something. Okay, well, if we look at a y value, 1 is the same as the x. So 1 and 1, 2 and 2. So in other words, y is the same as x. So it's just the line of y equals x. Eleanor spent 120 minutes at a sports centre. She played badminton for 50 minutes. She used the swimming pool for 1/6 of the 120 minutes. She used the gym for 20% of the 120 minutes. She then spent the rest of the 120 minutes in the cafe. Work out the total time in minutes that Eleanor spent in the cafe. Right, so we know badminton was 50 minutes. The swimming pool, she was in there for 1/6 of 120 minutes. So to work that out, we want 1/6. So we want 120 divided by 6. So we can do that with the bus stop method. Well, 6 can't divide into 1. What about 6 into 12? 6, 12. That goes twice. And 6 goes into 0, 0 times. So this is going to be 20 minutes in the pool. She used the gym for 20% of the 120 minutes. Well, 10%, we'll just take a 0 off. So that would be 12 minutes. We want 20%, so we want 2 lots of 10%. So it's going to be 12 plus 12. 2 plus 2 is 4. 1 plus 1 is 2. So we've got 50 minutes of badminton, 20 minutes in the pool, 24 minutes in the gym. Add this all up. 0 plus 0 plus 4 is 4. 5 plus 2 is 9. So 94 minutes spent doing an activity. To find out how long she spent in the cafe, we need to subtract the 94 from the 120 minutes. 0 minus 4 we can't do because 4 is bigger than 0, so reduce the 2 by 1 and give 1 across here. So 10 minus 4 is 6. 1 minus 9 we can't do, but 11 minus 9, that's 2. If you feel better, you can reduce the 1 by 1 and pass it over, but it's the same thing. 11 minus 9 is 2. So we're left with 26 minutes in the cafe. Eleanor got to the sports centre at 1:30 p.m. She had asked her friend to meet her in the cafe at 3 p.m. Did Eleanor get to the cafe by 3 p.m? Give a reason for your answer. Okay, well, we know that she spent 94 minutes doing some sort of activity. So, 94 minutes. And if we think of that in terms of hours and minutes, well, we know there's 60 minutes in an hour. So if we take 60 off of 94, we're left with 34. So 94 minutes is 1 hour, 34 minutes. So if we've got 130 and we add on 134, well, remember this is time we're working with. So 0 plus 4 is 4. But we got 3 plus 3, but think of it as like 30 plus 30 is 60. So actually that's a whole hour. So it's going to be 0, carry 1 across. So we got 3:04 p.m. So did she get there by 3 p.m? Well, 3:04 is after 3 p.m. So no. So it might look a bit odd adding like this, So it can be confusing, but if you think it's time, 30 minutes plus 34 minutes, that's going to be an hour and 4 minutes. So this is when she's going to be free. Question 13. The composite bar chart shows information about the number of people living in a village. And a composite bar chart just means you've got information in different parts of the same bar. Okay, so for example here, the number of people in 2000, this black area represents the number of men, the stripy lines are the number of women, and children up in this grey bit at the top. Write down the number of men living in the village in the year 2000. So men are just this black bit, so it's going to be to here. So we've got to work out what value this is. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes, total 100. So if we think 100 divided by 10 leaves 10. So each of these is worth 10. So that'd be 10, 20, 30, 40, 50, and 60. Okay, part B. Find the number of children living in the village in the year 2010. Okay, 2010, so that's here. We want children, so just this bit here. So we're going to start here. We could work out this total, or we could work out the total at the top and then take off this bit. But I know that each of these boxes is worth 10, so I'm just going to count in tens. 10, 20, 30, 40, 50. And finally for part C, for the people living in the village in the year 2020, find the ratio of the number of children to the number of men and women. So we've got to be careful how we read this. So it's going to be children to men and women. Or actually, if we put it as children to men plus women. Okay. So let's have a look at that. 2020. So children, we've got 10, 20, 30, 40, 50, 60, 70, 80. And then we want men plus women. Well, these are the men, these are the women. So men plus women will be here, which is 200. So we can just write it as 80 to 200. And they haven't asked us to simplify it, so I'm just going to leave it like that. Question 14. Jenny drives from London to Swindon at an average speed of 54 miles per hour. She drives for 1.5 hours. Work out the distance from London to Swindon. Okay, so she's driving for 1.5 hours. So in the first hour, she's going to drive 54 miles. In half an hour, well, she's going to drive half of that. So what's 54 divided by 2? 2 goes into 5, 2, 4, so that's twice. 1 left over. 2 goes into 14, 2, 4, 6, 8, 10, 12, 14. That's 7 times. So 54 miles in the first hour, then 27 miles in half an hour. 4 plus 7 is 11. 5 plus 2 is 7, plus 1 is 8. So total of 81 miles. Okay. And I can't fit that all in, but this is for 3 marks, the second part of the question. Alexi is using a map. The map has a scale of 1 to 25,000. So 1 centimetre on the map is 25,000 centimetres in real life. On the map, a road has a length of 6 centimetres. Work out the length in kilometres of the real road. So we've got 1 to 25,000, that's our ratio. But what we're saying is instead of 1, we've actually got 6. So what we need to do is multiply this by 6. Well, 6 times 0 is 0. 6 times 0, still 0. And again, 6 times 5, 5, 10, 15, 20, 25, 30. 0 carries the 3. And 2 times 6 is 12. Add the 3, 13, 14, 15. So we've got 150,000, and that's centimetres. Okay. Now, we want this in kilometres. At the moment, we've got it in centimetres. So we're going to convert. Now, I know that we've got 100 centimetres in 1 metre. So if we divide this by 100, so take 2 zeros off, we're going to have 1500. So we've got 1,500 metres, which is great. We've got it to metres, but we still want to get it to kilometres. I know there's 1,000 metres in 1 kilometre. So here we divided it by 100. Now we want to divide it by 1,000. Well, we can take off the zeros, or best way to do it is to think we've got 3 zeros. So decimal point at the end, we're going to move it once, twice, 3 times. So we're going to end up with 1.5 kilometres. We could put 1.500, but we don't need the zeros anymore because they're after the decimal point. So there we go. Question 15. Okay, so we've got 2 points marked on the coordinates. Find the coordinates of the midpoint of PQ. Right, okay, so the midpoint. So what I'm going to do is I'm going to draw a line. I'm going to measure it first of all. What's that? It's just under 8 centimetres. So the midpoint would be well, actually, let's do it accurately. The midpoint would be 7.8 centimetres. So the midpoint is going to be half of that. 2 into 7, 2, 4, 6. That's 3 times 1 remainder. And 2 into 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's 9. So we want to measure 3.9. So that's 1, 2, 3.9 is going to be right there. So I'm going to say that's halfway. So we can write that as minus 0.5. But on the y-axis, it's exactly 1. So the coordinates are going to be minus 0.5, 1. Okay, so we're going across first. It's to the left of the 0. That's why we've got the minus in there. But it's exactly on the 1. Question 16. Here is a quadrilateral ABCD. So quadrilateral just means 4-sided shape. And we've got the measurements on here, but they're all written in algebraic notation. All the measurements are in centimetres. The perimeter of ABCD is 52 centimetres. Work out the length of DC. And this is worth 4 marks. So if we know the perimeter is 52 centimetres, well, we've got this side, this side, this side, and this side. So we can add them up. So we've got, for here, we've got x plus 1. So this is our A to B. And then for B to C, so we can add on plus x minus 1. And we've got C to D, which is 2x. And then D back to A, we've got 2x minus 5. And we know that all of this equals 52. So we can start to add these up. We want to put all our x's together first. So we've got x plus another x, that's 2x, plus 2 more, that's 4x, 5, 6x in total. So let's cross those off because we've used those. So we've got 6x, then we've got plus 1, minus 1. So they cancel out. Minus 5, and that equals 52. We want to get the x's on their own, so the minus 5 we can move over here. When we move it over, we change the sign so that becomes a plus. So we've got 6x equals 52 plus 5. That's going to be 57. If we want 1x, it's multiplied by 6 at the moment, so we move it over. It's going to be divided by 6. So we've got x equals 57 divided by 6. So let's do that here. Well, 6 is into 57. 6, 12, 18, 24, 30, 36, 42, 48, 54. 60 would be too many, but 54 is 9 times. And we're going to put a 0.0, so we've got somewhere to put our remainder. So it's 54, so we've got 55, 56, 57, so the remainder 3. And 6 into 30, 6, 12, 18, 24, 30, that's 5. So x equals 9.5. Now, it's very tempting to stop here because we've worked out what x is. But the question doesn't say work out x, it says work out the length of DC. Well, we called it CD, but it doesn't matter. DC, CD, same thing. So DC is 2x. So we want 2 times 9.5. So 9.5 times 2. 2 times 5 is 10. 2 times 9 is 18. Plus a 1 is 19. 1 decimal place. So we need 1 decimal place in the answer. So our answer is 19 centimetres. Question 17. There are only blue counters, green counters, red counters and yellow counters in a bag. The table shows the number of blue counters in the bag. So we've got 30 blue ones. There's a total of 100 counters in the bag. Ashin takes at random a counter from the bag. Find the probability that the counter is not blue. Okay, well, it's going to be out of 100. We want the ones that aren't blue. Well, if 30 are blue, the one's not blue must be 100 minus 30. 0 minus 0 is 0. We can't take 3 away from 0, so we do 3 away from 10, which is 7. So we've got 70 out of 100. Again, they've not asked us to simplify it, so we can leave it like that. Part B. The ratio of the number of blue counters to the number of green counters is 2 to 3. Work out the number of green counters in the bag. Okay, so I'm going to draw a quick ratio table. So we've got blue to green is 2 to 3. We know we've got 30 blues. So we want to see how many times bigger is 30 than 2. So in other words, we're saying 30 divided by 2. 2 goes into 3 once, remainder 1. 2 into 10, 2, 4, 6, 8, 10. That's 5 times. So this is 15 times bigger. So we need to do the same to the greens. We need to multiply the 3 by 15. 3 5s, 5, 10, 15. 1 times 3 is 3, plus 1 is 4. So we've got 45 green counters in the bag. Bradley says the number of red counters in the bag is the same as the number of yellow counters in the bag. Can Bradley be correct? Give a reason for your answer. Right, so if we look at blue plus green, well, we're going to have 30, which were the blue ones, and 45, which were the green ones. 0 plus 5 is 5, 3 plus 4 is 7. Now we started off with 100 counters. So 100 minus 75, well 0 minus 5 we can't do, so we can't take 1 from the 0, so we need to go all the way back to here, reduce that by 1 to make it 0, pass 1 across, reduce that by 1 to make it 9, pass 1 across, 10 minus 5 is 5, 9 minus 7 is 2. So we've got 25, which needs to be our red plus our yellows. Now, if it's the same number in the bag, well, to find out how many, we'd need to divide it by 2. Well, if we do 25 divided by 2, we can just say 25 divided by 2. Well, actually, let's do it. 25 divided by 2. 2 goes into 2 once. 2 goes into 5. 2, 4. That's twice. Remainder 1. So let's put our point 0. So we've got somewhere to put the remainder. Decimal point. 2 into 10. 2, 4, 6, 8, 10. That's 5 times. So the answer is 12.5. So we can see can't have 12.5 counters unless you cut them in half. So can Bradley be correct? So incorrect. Anything to that effect, you could say because this is an odd number, we can't have the same number of reds and yellows. Something along those lines. Question 18. There are 240 cans of drink on a shelf. Each can contains cola or lemonade or orange. We've got the number of cans of cola to the number of cans of lemonade to the number of cans of orange equals 5 to 3 to 2. So that means every time we've got 5 cans of cola, we've got 3 cans of lemonade and 2 cans of orange. A half of the cans of lemonade and 1/12 of the cans of orange are removed from the shelf. Work out the number of cans of cola as a percentage of the total number of cans of drink remaining on the shelf. So we've got a 5-mark question here, loads of information. We want to try and get rid of some of these words and just have some numbers or something nice and easy for us to understand. So because we're dealing with ratio, I'm going to start off by drawing a ratio table. Okay, so, and we're going to have a line for our headings. What are we going to need to have? We're going to have cola, lemonade, orange, and we'll give a total column as well. We know at the moment the ratio is 5 to 3 to 2. If that's all we had, well then we'd have 5 plus 3, which is 8, plus 2, which gives us 10 in total. But we know actually we've got 240 cans in total. So we can put that on a new line. Okay. Now we then start talking about half of the cans of lemonade and 1/12 of the cans of orange. So really we want to know how many cans we've actually got of each of these. Well, we can use this. So what we want to say is, well, how many times bigger than this row is this row? And the way we do that is we look for a column where we've got 2 numbers in it, and we take the bigger number, the 240, and we divide that by the smaller number. Well, here we can just cancel the zeros, so we've got 24 divided by 1, which is just 24. So this is 24 times bigger. So if we want to know how many cans of cola we've got, we need to multiply 5 by 24. So 5 times 4, we've got 4, 8, 12, 16, 20. So carry the 2. 2 times 5, well that's 10, plus the 2 is 12. So we've got 120 cans of cola. For lemonade, we do the same thing, but we're going to multiply the 24 by 3. Well, 3 times 4, 4, 8, 12. 2 carry the 1. And 2 times 3 is 6, plus 1 is 7. So we've got 72 cans of lemonade. And for orange, we're going to be 2 times 24. 2 times 4 is 8. 2 times 2 is 4. So we've got 48. And if we want to check, we can make sure that this adds up to 240. Okay, trust me, it does. But if you want to check that, that's fine. So now we've got that, we can start to look at what happens here. So half of the cans of lemonade and a 12th of the cans of orange are removed from the shelf. Well, let's find out how much half of the cans of lemonade are. So lemonade, 72. We want half, so we're going to divide that by 2. Well, 2 goes into 7, 2, 4, 6, that's 3 times, remainder 1. And 2 goes into 12, 2, 4, 6, 8, 10, 12, that's 6 times. Okay, so 36, and we'll put lemonade removed. Okay, now we can do the same thing with orange. Okay, so we've got 1/12 of the cans of orange are removed. Well, we've got 48. So, well, really what we want with this one is, let's do it over here. We want 48 divided by 12, 1/12. So with this one, it's best to just do your 12 times table. 12, 24, 36, 48. So that's going to be 4. So we've got 4 orange removed. So work out the number of cans of cola as a percentage of the total number of cans of drink remaining on the shelf. Well, we know the number of cans of cola is unchanged, 120. We did have 240 on the shelf, 240, but we are going to take off the 36 cans of lemonade and the 4 cans of orange. Well, this is quite a nice one, because 36 plus 4, well, if we just start with 36, 37, 38, 39, 40. So we've got 40 cans that are going to be removed. So 240 minus 40 should be a nice straightforward one. 0 minus 0 is 0. 4 minus 4 is 0. 2 minus nothing is 2. So we've got 200 cans remaining on the shelf. So we've got 120 of them are cola. So we've got 120 out of 200. And it says work out the number of cans of cola, which is this, as a percentage of the total number of cans remaining, which is this, as a percentage. So we're going to need to multiply that by 100. We've got quite a few zeros here, so we can do some cancelling. So we're multiplying up here, dividing at the bottom, so we can cancel a 0 here with 1 at the bottom, another one here with a 1 at the bottom. So we end up with 120 times 1, so it's still 120, divided by 2. So 120 divided by 2. 2 doesn't go into 1, 2 goes into 12, 2, 4, 6, 8, 10, 12, that's 6 times. 2 goes into 0, 0 times. So we end up with 60%. And we can put that down here. Question 19. Write 500 as a product of powers of its prime factors. Okay, so we're going to have 500. So let's split this up. Let's look at what numbers go into 500. Well, you could do it different ways. I'm going to say, well, we can do 5 and 100. 5 is a prime number, so we can stop here. We'll just work on the 100. Well, I know 100 is 10 times 10. Okay, 10 is not prime, so we can keep factorising these ones. Well, what numbers multiply together to make 10? Well, we can have 2 times 5. 2 and 5. And 2 is prime, and 5 is prime, so we stop there. And this 10 is also going to be 2 times 5, and they're both prime. So we just want to multiply all of these together. So we can say that 500 is equal to, well, it's going to be 2 times another 2 times 5 times 5 times 5. If you want to, you could write it as 2 squared times 5, 1, 2, 3, cubed. But either format would do. And that gets you 3 marks. Okay, question 20. Work out 1 3/5 plus 2 1/4. Give your answer as a mixed number. Right, so with these ones, it's always up to you if you want to add the whole numbers first and then the fractions. For something like this, I like to convert this into an improper fraction first so that I don't then have to remember, do I have to add things to the whole numbers or not? So I'm going to convert them straight away. So I'm going to say 1 3/5, turn it into an improper fraction. So I just want it in fifths. And the way you do that is you say 1 times 5 is 5, plus 3 is 8. So we've got 8/5. And for the 2 1/4, 2 times 4 is 8, plus 1 is 9. So we've got 9/4. So we've got 8/5 now, plus 9/4. So we're going to say, well, we've got different denominators. Does one denominator go into the other without remainder? No. So in that case, we're going to have to change both denominators of these. So we'll say, well, what's the common multiple of these? So what number does 4 and 5 go into? And a nice way to do that is to just multiply them together. So 4 times 5, 5, 10, 15, 20. So that means we can write both of these fractions as being over 20. The 5 to the 20 we multiplied by 4, so we're going to multiply the 8 by 4 as well. So 4 times 8, 8, 16, 24, 32. So these are equivalent fractions. We're just doing it so that we can have 2 with the same denominator. Now with the 9/4 or 9/4, to turn that into 20ths, we'll say, well, how many times did we multiply the 4 to get 20? 4, 8, 12, 16, 20, that's 5. If you remember, we did 4 times 5, so it's like we're doing the opposite. So this one multiplying by 5, so we need to multiply the 9 by 5 as well. And 5 9s, 9, 18, 27, 36, 45. So now we've got the denominators the same, so that's going to stay the same in the answer. We just want to do 32 plus 45. 2 plus 5 is 7, and 3 plus 4 is 7. So we've got 77 over 20. They've asked us to give your answer as a mixed number. Right, so we want to see how many times does 20 go into 77 first of all. So let's think our 20 times table. Well, 20, 40, 60, 80 would be too many, so we're going to stop at 60. So that's going to be 3, the whole number. And how many left? Well, if we do 77 minus 60, 7 minus 0 is 7, 7 minus 6 is 1. That means we've got a remainder of 17/20. And part B, show that 2 2/3 divided by 6 equals 4/9. So again, what I'm going to do is I'm going to turn the 2 2/3 into an improper fraction. So 2 times 3 is 6, plus 2 is 8. So we've got 8/3, or 8/3. And we want to do 8/3 divided by 6. Well, when we're dividing, it's much easier to divide a fraction with another fraction. And the way we can turn this 6 into a fraction is just by making it 6/1. It's not changed. 6 divided by 1 is still 6. But what it means is we can then apply KFC, which hopefully you remember means keep, flip, and change. So we keep the first fraction. We're going to, it depends on which you think of flip. I always think of the fraction flipping. So we're flipping it upside down. So instead of 6/1, it becomes 1/6. And we change, instead of divide, we change it to multiply. And we can just do 8 times 1, which is 8. 3 times 6, 6, 12, 18. So we've got 8/18. Now these are both even numbers, so we can divide top and bottom by 2. 8 divided by 2, 2, 4, 6, 8 is 4. And 18 divided by 2, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's 9 times. So we get 4/9, which is what they've asked. And that was for 2 marks. Question 21. Simplify 2 to the power minus 5 times 2 to the power 8 all squared. So when we're multiplying the same number but with different powers, we add the powers together. So if we think we've got minus 5 and a positive 8, so think of a number line. We've got a 0 here, minus 5 down here. If we want to add 8 to it, well, it's going to take us 5 to get to 0, and then 6, 7, 8, which would be 1, 2, 3. So minus 5 plus 8 equals 3. So this bit in the brackets is going to be 2 to the power 3, or 2 cubed. So now we've got 2 cubed, still in brackets, and then all of that is squared. Or in other words, 2 cubed times 2 cubed. And if you want to write this all out, well, 2 cubed means 2 times 2 times 2, and another 2 cubed is 2 times 2 times 2, which is basically 2 to the power 1, 2, 3, 4, 5, 6. And that's our answer. Your answer is a power of 2, 2 to the power 6. Question 22. Work out 0.004 times 32. Sorry, times 0.32. I'm going to ignore all the decimal points. I'm just going to do it as 4 times 32. 4 times 2, or 2 times 4 is 8. 3 times 4, 4, 8, 12. So we've got 128. Now we can put the decimal point in. So we had 1, 2, 3 decimal places here, and 1, 2 decimal places here. So that's 5 decimal places altogether. So decimal points here, we're going to move it 1, 2, 3, 4, 5 times. And then fill in these gaps with zeros. So we've got an answer of 0.00128. Question 23. A car factory is going to make 4 different car models, A, B, C and D. 80 people are asked which of the 4 models they would be most likely to buy. The table shows information about the results. So 23 people said A, 15 said B, 30 said C and 12 said D. The factory is going to make 40,000 cars next year. Work out how many Model B cars the factory should make next year. Okay, so B, so we had 15 people. So we had 15, and this was out of 80 people. Okay, well, we can think, well, it's not really 80. We've actually got 40,000 cars. So we want to know how many times bigger is 40,000 than 80. So it's like we've got 80 people, then another 80 people, then another 80 people, keep going until we get to 40,000. So really what we want to do is 40,000 divided by 80. Well, we can cancel a 0, so we've now got 4,000 divided by 8. 8 into 4 doesn't go. 8 into 40. 8, 16, 24, 32, 40. So that's 5 times. 8 into 0 goes 0 times. 8 into 0 goes 0 times. So it's 500 times bigger. So if it was 15 people when we only had 80 being asked, if we've got 40,000, it's now going to be 500 times bigger than 15. So we're going to have, well, what we want is 500 times 15. What I'm going to do is ignore the zeros for now and just say, well, let's do 5 times 15. This is a bit like with decimals. It's good to ignore them and then put them in afterwards. So 5 times 5, we've got 5, 10, 15, 20, 25. 1 times 5 is 5, plus 2 is 7. Now we put our zeros back on. 1, 2, 1, 2. So we are going to have 7,500 Model B cars. We can put that down here. Question 24. Rizwan writes down 3 numbers, A, B and C. And we're told that the ratio of A to B is 1 to 3 and the ratio of B to C is 6 to 5. Part A1, find A to B to C. Right, so let's draw a ratio table. I'm going to use my ruler again. So we've got A, B, C, and I'm going to have a total. The ratio of A to B is 1 to 3. The ratio of B to C is 6 to 5. So I can't write it on the same row because we've got a different number for B. So I can write it below, 6 to 5. And at the moment, actually, I can't do anything with the total because I haven't got all 3 on a row. But I have got 2 numbers in the same row here now. And I've got 3 and 6, so I can see, well, actually, we're doubling it. To get from 3 to 6, we're timesing it by 2. So we can do the same with this row. We multiply the 1 by 2. 1 times 2 is 2. So we've now got it. So the ratio of A to B to C is 2 to 6 to 5. Now you could say, well, why don't we do it 1 to 3 to something? And we could, but if we're going to go backwards, well then we're going to need to divide by 2. And 5 divided by 2, because 5 is an odd number, we'd end up with a decimal. And you don't want a decimal when you're writing a ratio. You want them all to be integers or positive numbers. So we're going to leave it like that. Okay, part B. Express A as a fraction of the total of the 3 numbers A, B and C. Well, A, we've worked it out already. That's the benefit of doing a table. We've already got that A is 2. What's the total? Well, it's going to be 2 plus 6, which is 8, plus 5, which is 13. So there's our fraction. Now we've got another part to the question. Let's move it up so we can see what this is worth. This is worth 2 marks. Emma writes down 3 numbers, M, N and P. We're told that N equals 2M, P equals 5N. And they want us to find M to P, so the ratio of M to P. Okay, well, we know what N is, so what we can say is, well, if P equals 5N, well, let's substitute this into here. So it's 5 times 2M. 5 times 2 is 10, so it's going to be 10M. Okay, I'll put the P back in. So this is going to help us, because now we've just got it in terms of M and P. What we've got to do is think of which way round do they go, because they want M to P. Well, if P is 10 lots of M, well, that's saying that P is bigger than M. And how much bigger is P than M? Well, it's 10 times bigger. So if we're going to write M to P, it's going to be the same as 1 to 10. Question 25. A storage tank exerts a force of 10,000 newtons on the ground. The base of the tank in contact with the ground is a 4 metre by 2 metre rectangle. So that's this base here. So that's 4 metres by 2 metres. Work out the pressure on the ground due to the tank. Well, they've given us the formula here. They said the pressure is the force times the area. And they've even given us the force. So this is 10,000. We just need to work out the area. Well, the area of a rectangle is the length times the width. So 4 times 2, or 2 times 4, which is 8. So we want 10,000 divided by 8. Well, 8 doesn't go into 1, so 8 into 10 goes once, and then 9 tenths, so that's remainder 2. 8 into 20, 8, 16, that's twice, and then 17, 18, 19, 20, remainder 4. 8 into 40, 8, 16, 24, 32, 40, that's 5 times, and 8 into 0 goes 0 times. So we've got 1,250. It's pressure, but they've already given us the units, newtons metre squared, so we can just put our 1,250 in here. Question 26. Solve 5x divided by 2 plus 3 is greater than 18. Okay, so the fact we've got an inequality doesn't matter. You can. Some people like to change it into an equals and then turn it back. I say just leave it. Leave it as it is. We want to get the x on its own on one side. So what we're going to do is move the plus 3 to this side. And because we're moving it across, we're going to have the opposite operation. So it's going to become a minus 3. So we'll end up with 5x over 2. Still the same sign. 18 minus 3, so it's going to be 17, 16, 15. Now we want to get rid of this 2. Well, it's divided by 2 at the moment, so if we move it across, it's going to become times 2. 15 times 2. 2 times 5 is 10. 1 times 2 is 2. Plus 1 is 3. So we end up with 5x. The 2's moved across. The sign stays the same. 15 times 2 we've just worked out is 30. We want to be left with just x on the left. So we want to move the 5 across. It's times at the moment. So move it across. The opposite operation to times is divide. So we want 30 divided by 5. 5, 10, 15, 20, 25, 30. That's 6 times. So we're going to have x is greater than 6. Okay. Part B. Factorise x squared plus 10x plus 9. So in other words, we want to put this in brackets. And because it's a quadratic, because it's got a squared in there, we know it's going to be something that looks like this. To get the x squared, we're going to need to have an x times an x. And to get 9, we're going to need 2 numbers multiplied together. So it could either be 1 times 9, or it could be 3 times 3. But what we need is when the numbers are added or subtracted together, we're going to need them to add up to 10. Now, if we do 3 plus 3 or 3 minus 3, we're never going to get the 10. But if we do 1 plus 9, we can get the 10. So we know that we need the 1 and the 9. And because everything's positive, and we can see x times x gives the x squared, 1 times 9 gives the 9, 1 plus 9 gives the 10, so they must both be pluses. And that's exactly what we're going to put in here. That's quite a nice one for us. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you get updated when I add more videos, and I look forward to seeing you again soon. Thank you.